Hello and welcome to our expert webinar today. Thank you for joining us and the Cazena team as we talk about instant migration to cloud data lakes. I'm really excited to bring our speaker to you today. Lavan Chetty is a vice president with Cazena, focusing on product and solution architecture. He's got tons of experience with cloud migration. So without further ado, please take it away, Lavan.
Thanks, Anna. Hi, everyone. Thanks for joining us today. And the driver behind this was that we've had lots of conversations around with organizations that are looking to migrate their existing on-premises, data lakes or analytic clusters. And we found a couple of drivers for these. Some of the products like CDH and HTTP are going end of life in about 14 months. With others, some of their on-premises infrastructure might need a refresh. So just to set the stage for today's discussion, we're going to focus on organizations that have decided to migrate on-premises workloads to the cloud, right? So if you're planning on doing a migration and you're going to stay on-prem, for example, adopting CDP private cloud, there are portions of the session that you might find valuable, but we're going to be focusing on the cloud. So we'll go through the approach that Cazena takes to do these migrations, how our instant data lake accelerates that process, and then we'll go through a couple of case studies for various scenarios that run through that. And there's a Q&A chat window which you can ask questions as we go along. So let's start with the approach that we take. When migrating a production environment, from a Cazena perspective, we tend to assess this entire process through a lens risk, right? These are production processes, and they are users and operational processes that rely on these environments being up and providing them data, right? So we need to make sure that we have minimal amount of disruption to all of those consumers. The approach that we take is defined by 7 distinct steps. We don't have a ton of time today, so I'm going to just touch briefly on each point and possibly give you an example of some of the complexities that we try to overcome with each one. The first, obviously, is to start with the existing environment and to assess the data and the workload that needs to be migrated. So for example, starting to tackle questions like, what is the scope of the data that needs to be migrated? Are there archival sets or unused data sets that could be catered for differently, as you go through this migration process? Or are there derived data sets that are just no longer needed? From an engine perspective, making sure that, what engines are used to support the workloads, and what are the versions of those current engines? Because as you go through these migration processes, there are typically version differences from the source to the target. And then finally, what orchestration methods are used for those end-to-end flows, right? Something that people typically don't think of initially is also authentication and authorization, because as technology progresses, those methods end up changing or evolving slightly. So paying attention to the impacts of the authentication and authorization models that you use in your current on-prem versus what will be used on in the cloud could result in some differences in the way you run your operations. Once we've done with that scoping, right, the next step is to design and build a target environment that you're going to be moving all of these workloads to. And so this process is not just about technology, right? You're going to be adopting a new set of analytics stacks, sure, but you also have to make sure that that target can cater for the workloads that you're going to be moving from a production environment, right? And so that means that that workload is going to drag along with it all of the security and compliance controls that you've probably built up over years for your existing production environment, right? But the end goal is that this new environment would need to cater for 100% of those compliance controls and security protocols on day number one. Once we have this target environment up, right, we then need to figure out our target data architecture. So I'm moving on to step number 3, where we're looking at data and metadata. So on-premises systems typically restrict us to HDFS, or some form of SAN or attached disk. However, once you start moving to the cloud's going to provide you with multiple options, with the default being the object store for the cloud, as that's what they would prefer you use as your primary persistence layer. And there's huge value to that. You get huge cost performance on, from the object store. You also get incredible reliability from the cloud object stores. Unfortunately, there are some workloads that don't translate directly to the cloud object store. There are some obvious candidates. So if you have workloads that leverage HBase or Kudu, those engines rely on a storage layer that needs quick random access, which you are not going to get from a cloud object store. Right? But there are some less obvious scenarios. So I'll give you an example of one of those, because there's a fairly common pattern that people use in analytic environments, where you use an alter table statement to swap a temporary and a permanent table to minimize the downtime of data availability. Right? This operation is very, very cheap on a traditional file store, right? Because it's just a metadata change. However, this same operation on an object store is significantly more expensive, as what ends up happening under the covers is that operation is actually a move operation. So every single one of the files have to be moved from one location to another. Right? So that could drastically impact the SLAs or the expectations that people have for data availability. So those kinds of decisions then need to drive how you pick the appropriate split between the cloud object store and more traditional HDFS storage layers. And those choices obviously will then ripple in through your entire metadata layer, as as those are typically going to result in some sort of storage location changes. If we start to move on to the to step number 4, right? We now have a foundation of data. We've got a foundation of metadata. So we can now start to peel off workloads and start the migration of actual workloads. Right? This is the one step where there's the largest number of variables, right? With one of the big variables being engine version differences. And so at a minimum, you really need to start to understand what impacts these version changes can start to bring in. Right? And sometimes that choice might be, fairly explicitly avoiding new capabilities. And an example of this is that most of the new stacks, whether you're moving to CDP or even the newer versions of EMR, they all support Type 3, which ends up having the transactional options for for tables on by default, right? But those new capabilities have ripple effects, and things like Spark workloads that rely on these Hive tables, they currently don't support those transactional properties by default, right? So you're going to have to make a choice there as to whether you decide to refactor your Spark workloads or just turn off that capability for the tables as you do your migration, right? And once all those workload options have been catered for, you then have to deal with all of the ripple effects through the orchestration that you use to control all those workloads. So once we can now move on to step number 5, right? So we've got our workloads and orchestration moved across, and we now have to start doing some level of optimization. And the reason for that is that if you use the cloud in the same way as you use on-premises infrastructure, and you use all the techniques that you use on-premises, you will end up with a fully functional system, but you'll most likely end up with higher cost performance. Right? The combination of all the new engine versions, as well as the wide range of compute options in the cloud, typically means that if you just choose the right combinations there, you'll generally end up with the same cost performance that you do on-prem as the worst case scenario, right? But in most cases, you can significantly increase your cost performance if you can start to exploit rather than just use the cloud. And our recommendation here is that if you don't have significant cloud experience, you really want to rely on the experts here to start to shorten those timescales to make good choices. Because the good and the bad of the cloud is that it gives you a lot of options, and those options evolve fairly frequently. So evaluating all of the combinations of options can be a really, really time-consuming effort. And then the final piece of the migration puzzle, right, which is ensuring that all of the tools that interact with your system, for example, data visualization tools or downstream processes that are consumers of data, can still connect and interact, especially if your authentication and authorization models have evolved through this migration process, right? But at the end of the day, it's those consumers that that rely on all of this data. So that final piece of the puzzle is really important. And then finally, as we move on to step number 7, we can't forget that once we complete the initial migration, this is now the new production system, right? And because it's the new production system, it requires all the behind the scenes processes to ensure that the underlying infrastructure stays healthy and the overall systems run in a reliable and performant manner, right? Just like your original on-prem system. So you'd need to have a whole range of processes that are living behind the scenes that can do things like, replace bad VMs, deal with, cloud provider maintenance schedules, software upgrades, vulnerability assessments, patching, et cetera, et cetera. So all of those would need to be built up into the cloud. So if we look at how this is traditionally done, it's people typically tackle this in a waterfall manner, and it results in a timeline that that has a reasonable amount of range. If you have a smaller system with fairly consistent workloads, you could probably achieve this in about 6 months. But we've easily seen that for more complicated workloads that rely on multiple processing engines, have fairly complex orchestration, this could easily span into a year-long exercise just to achieve the migration. So are there options for us to optimize this process, right? And so one way to accelerate that is to use automation to drive certain steps in the process that are independent of the workload. Right? So, for example, for step number 2, the provisioning, the configuring, and securing of cloud resources can all be automated, right? And that's just due to the inherent nature of the cloud. So, in step number 2, there's typically hundreds of manual steps that need to be performed across a wide number of roles within most organizations, right? So you don't just have the number of steps that need to be done, but also all of the coordination between cloud architects and networking resources, DevOps, SecOps, et cetera, to be able to produce these production level environments, right? And that can all be fully automated so that you have one of these target environments ready immediately. Another step that can be automated is step number 5. So, optimizing cloud infrastructure here can be an automatable process as well, so that those timelines can be significantly reduced. Here at Cazena, we use an extensive set of metrics that we build up based on actual workloads that we've benchmarked across a number of different cloud resource combinations. And so what this allows us to do is make an informed starting point for workloads running in the cloud, rather than just trying to mimic on-premises infrastructure in the cloud. Right, so we can do this through a workload lens and understand what kind of infrastructure is required for a particular workload based on the SLA that is typically expected for that workload. And then finally, all the grunt work that comes in the last step, right? So all of the cloud ops and the DevOps and the SecOps that are in place for it to be, a running production healthy environment, that can be automated as well. And so what we propose when performing these migrations is that for the data lake component, rather than building all of those components from scratch, you can accelerate this process by leveraging a production-ready data lake. Right? So this is where all of the data lake capabilities are just delivered as a SaaS solution. Right? Because it's delivered as a SaaS solution, that means that provisioning, configuring, ongoing operations are all automatically catered for. Right? All of those complicated security tasks are catered for automatically at the point of deployment. Right? And then there's built-in SecOps and DevOps to ensure that each one of those processes maintains that stance as the systems evolve. Right? So these environments still give you, full access to all of the engines that you require, the various storage layers, whether you're using cloud storage, HDFS, a combination of both. They allow you to, plug all of these environments directly, into your on-premises infrastructure. But the key bit that is all automated are the surrounding portions of all of the SaaS orchestration that is needed to set up all of these environments so that you have a fully production-ready environment up front. All data that's flowing into these environments gets automatically encrypted, all communication is encrypted, and then all the ongoing operations that need to happen to ensure that these environments, maintain their health states and security postures. So I'm going to go through a few examples of some of our customers and go through how they have leveraged these migration steps that we have to move from their existing on-prem environments, into the Cazena Instant Data Lake. So the first one I'm going to start with is a steel manufacturer. And this is fairly typical for a lot of organizations that we have interacted with. They started to deploy a range of sensors on their production lines, and that new stream of data forced them into adopting some new technology that could deal with not just streams of data, but also a new range of processing that needed to be done on those streams. So their initial step was they adopted the Hortonworks environment, they deployed it on premises, and it had all the capabilities that they required to solve these problems. But the team was spending the majority of their time keeping the environment running and healthy, which meant that they weren't able to spend the rest of the time in actually producing analytics on all of this new data, right? So they ended up having a really, really slow onboarding of users. They were spending way too much time, maintaining the cluster reliability. And one of the corners that they cut was they weren't able to turn on all of the security configurations, which meant that, that exacerbated the slow onboarding of users because you don't have a robust authorization model. So they eventually decided that they were going to focus just on data and analytics, and they would they adopted the Cazena Data Lake to take care of all of the underlying provisioning, security, DevOps, SecOps to support all of their workloads. So their migration was in that shorter time frame. Right? They were able to migrate all of their data, metadata, as well as all the workloads and the orchestration in just a 30-day period. And in addition to that migration, things that they got free of charge through that process was a whole range of authentication and authorization that they didn't have in the on-prem system, as well as the reliability of using a service, meant that they now were rapidly able to onboard new users, new use cases, and they were able to start to, not just perform this migration in a short period of time, but then start to bring on whole new workloads because they weren't focusing, on the underlying platform anymore. The second example is a financial services customer. So this one is a little bit different than the previous. They've already started their journey to the cloud. So their initial workloads that they started to move were operational systems. So they had moved a few operational systems into the cloud, but what they found through that process was that they really struggled to find cloud ops and DevOps skills. And because they're a financial services organization, the manual application of the rigorous security controls was taking a really, really, really long time. So one of the things that they were really looking for was that they currently use an on-premises MapR cluster that did the majority of the data processing for an invest application that that their customers use. And due to the ramping up of the number of users that they were going to roll out this mobile application to, they needed something a lot more flexible than the existing on-premises infrastructure. Right? But the barriers for them, were skills and security. So here, the solution ended up being, because these the instant data lake is production ready, right? All of the security controls that they required were there on day number one, right? And what ended up actually being interesting is that there were actually some security controls that were surpassed, because there were things that were done automatically in the instant data lake, things like mandatory encryption that were just a lot more difficult for them to achieve on premises. So they were able to take one of the core data processing workloads and migrate it from the on-premises system into the cloud-based data lake in about 2 weeks. But the most interesting part of that was, once we started to do the workload optimization around that, what we found was that for that particular type of workload, we could actually run the workload on half the resources and still get twice the performance out of it, right? So from a cost performance perspective, we ended up with 25% of what the on-premises cost performance was by optimizing that workload to exploit the cloud rather than just use it. And then the final one is a global nonprofit. This was a Cloudera Data Hub customer. And the problem that they really faced was that CDH was going end of life. Right? They knew that they wanted to leverage the cloud for their new deployment, predominantly for flexibility. Their workloads were extremely spiky, right? Because of the nature of their business, they get infrequent sets of new data, but those sets of new data can be fairly large. So they have an extremely spiky workload, which meant that their on-premises infrastructure was utilized to the peak when they got new data sets, but for the rest of the time was being very, very heavily underutilized. Right? So their vision was, it would be great if we could use the flexibility of the cloud to solve some of these problems, but they had no skills to figure out how do you now adopt this cloud deployment. Right? So again, they took the approach of, we can just focus on our data and our workload and rely on the fact that the Cazena Instant Data Lake would allow them to start to leverage the cloud without having any of those cloud ops, DevOps, or SecOps skills. they're actually in the process at the moment of migrating all of their existing, data and workloads. And again, like the steel manufacturer, they'd also, gotten their on-premises environment to, to a stable state by not turning on all of the security capabilities. Right? So one of the benefits that they're getting out of this new environment as well is is a fully robust authentication and authorization model, which should expand their usage again because they can now control access to data, etc. And of course, they now get this more flexible environment because what it means is that the environment can flex only when they get these new data sets. And for the rest of the time, they have a footprint that's scaled down to the workloads that they run on a daily basis. So if any of you are interested in exploring this approach that we take, the initial step is a migration assessment workshop. As I mentioned, this is a risk-based approach that we take. So we basically go through a framework that we have that goes through a whole range of questions for your on-premises system and your existing workloads, so that we can then assign a risk score to each of those categories, right? And then we aggregate across that so that you can get a really easy view into, where are the risks when you're approaching this migration process? What are the things that are going to be fairly simple to do? And then what are the things that, that definitely needs to be some focus on, or there could possibly be some, some refactoring effort. And the end state of that is, is a risk report that you can use, irrespective of whether you decide to use the Cazena Instant Data Lake or not.
Thank you so much, Levan. That was a tremendous amount of information in 30 minutes. We will make the recording available. I want to invite any questions that anybody has. You can put it in the chat window or the question window right at the bottom of the screen. And Levan, I'll ask you one. Which part of this process is the most underestimated? So which part do people not typically allow enough time for?
I think that the one that we found is generally the data movement, because I think most people just think, oh, I can just lift and shift all of my data from HDFS into the object store. But those examples that I gave, where there's just certain workloads that it might not be obvious, but are just not applicable to use the same type of data movement capabilities with an object store, where people get tripped up, right? Because even though the cloud providers have done a really good job of making the object store to look like a file system, there's certain operations on them that just work differently than HDFS. So so I think that that's one of the things where the initial thought there is that this should be a fairly simple process. So we found organizations not putting the right level of thought there that they should be.
That makes sense. Thank you so much. I'd like to put in one more plug for the migration assessment process. This is a complementary scoping. So regardless of the outcome, you'll have a value, whether you move forward with Cazena or not. So the migration assessment, you can contact us anytime to get started with that, or get hands-on by trying the Try Cazena experience. If you go to our website and click the big green Try Cazena button, you can get right into a trial version of the Instant Data Lake. We will make this the recording available for you to listen back and hear all this great information. I'd like to thank our presenter again, Levan Chetty with Cazena. Thank you, Levan.
Oh, pleasure, Hannah. Thanks everyone for your time today.
And we'll see you on the next one. Thanks everyone for joining today.